So if you want to work out the resultant vectors, we can use a triangle method. So in a triangle method, we first select a scale. We'll draw the first vector, then we draw the second vector. From tail of the first to the head of the last, that will be the resultant. But what if the two vectors are perpendicular? Then we can use a Pythagoras theorem as well. If two vectors are perpendicular 90 degrees, and we want to work out the resultant, the magnitude. So how to work out a magnitude? Like we first do the first vector. In this case, we don't have to scale. Why we don't have to scale? Because we are using a calculation method. So first we have two vectors, 110 newtons. We have two vectors, 110 newtons and 70 newtons. And we want to work out the resultant of these two vectors. The two vectors are perpendicular or 90 degree to each other. So in this case, we will draw the first vector. Any one of them you can draw. We do the first vector, then we draw the second vector, and the resultant is from tail of the first to the head of the last, that will be the resultant. So when two vectors are perpendicular, the triangle, it will be a right angle triangle, and for a right angle triangle, we can use a Pythagoras theorem that the hypotenuse square equals base square plus perpendicular square. So this is a hypotenuse for us. What about the base? The base actually depends on which angle we need. The direction. So if the angle is given here, then this will be referred as a base. But if the angle is given with a vertical, in the question, if the angle is given with a vertical, then this will be the base, because the angle is always between the base and the hypotenuse. So you can, any one of them could be a base, because the angle is always between the base and the hypotenuse. So if we need the angle with the horizontal, so with reference to the angle, this will be the base, and opposite to the angle, that will be the perpendicular. Now we use a Pythagoras theorem. As we know, the hypotenuse square equals base square plus perpendicular square. So the base is 110, so 110 square plus perpendicular, which is 70 square, is hypotenuse square. So we take a root, so the hypotenuse will be equals to 130 newtons. Yes, you can say adjacent and opposite, it's the same thing. Instead of saying base and perpendicular. So it does not make difference. Same way, if I need the direction, what is the meaning of the term direction here? Direction, as we know, angles are also refers to direction. Usually, in terms of the vector, when they say a direction, they refers to an angle. But it can be upward or downward, right, left. But usually the direction is refers to the angle relative to east, west, north, or south. So if I need the direction from 110 newtons or horizontal, so we can use the trigonometric ratio. We have the sine theta, which is perpendicular over hypotenuse. Cosine theta is base over hypotenuse, and tangent theta is perpendicular divided by base. So these are the trigonometric ratios. You can remember from, like some people have curly brown hair till painted black. So that's just a simple way to remember these. So if you want to remember the trigonometric ratios, you can remember from this as well. So here sum means sine. People perpendicular have hypotenuse. So this is for sine. Curly cosine, brown base, and here's hypotenuse. Tangent theta till perpendicular base. Yes, Mar, you have heard SOH. How you pronounce this? SOHCAHTOA. Okay, you adjacent and opposite. Yes. Yes, Amar, you have sent a message about sine theta. So how you remember this? So anyway, like if you remember adjacent opposite, that's also fine. Sine is opposite hypotenuse, cosine is adjacent. Okay, okay. You learn in this way. Okay, that's fine anyway. Like it's, I'm not saying change because you have already appeared for the maths exam. Any method you find it easy, convenient, use that. So sine is opposite hypotenuse, cosine is adjacent hypotenuse. That's fine. But I'm very used to use perpendicular base and hypotenuse. That's why throughout the session, instead of adjacent and opposite, you will find me that I'm using base and perpendicular rather than adjacent and opposite. So we can work out the angle by using the trigonometric ratio depending on what are the like either we have a perpendicular base or adjacent and opposite. We can use that. Any one which you remember, you can use that. Like there's no deduction of the marks. Then if you use a parallelogram method, if you use a parallelogram method, the both vectors should start from the same point. Then we draw an arc, intersection of the arc, we draw the diagonal, and that will be our resultant. Then the vector decomposition, or it's also known as the resolution of the vector. Resolution of the vectors means we resolve the vector into the component, the horizontal and the vertical components. So if you want to resolve the vector into component, like example, so there's a vector which is 30 newtons and it is making angle 20 degrees to the horizontal. So this vector will have two components. One of the component is a horizontal component, like a force of 30 Newton acting at an angle of 20 degree to the horizontal. So part of the force is acting horizontally and part of the force is acting vertically. And the vertical component you can draw here or you can draw at this point. You can also draw at this point, it does not make difference. So the vector will have the two component. One is acting like if a vector is making an angle with horizontal or with vertical, the part of the vector will be there in the horizontal direction and the part of the vector will be there in the vertical direction. So how we can work out the part in the horizontal direction or vertical direction? Look, because this is an angle, so this is what? Base or adjacent. This will be the hypotenuse and this one is a perpendicular. Now, if I want to work out the base, I can use the trigonometric ratios. Like if I use cosine theta. So cosine theta is what? It is base over hypotenuse. So I can say cosine and the theta is the angle which is 20 degrees. The base we don't know. And what about the hypotenuse? The hypotenuse is 30. This 30 is divided, other side it will be multiplied. So I can say 30 cosine 20 is equals to the base. So base is equivalent to what? The base is equivalent to or equal to 30 cosine 20. Same way, what about the perpendicular? We have the trigonometric ratio like sine theta is perpendicular divided by hypotenuse. So the theta is 20, so I can say sine 20. The perpendicular and the hypotenuse in this case is 30. It will be multiplied. So 30 sine 20 is equals to perpendicular. So the perpendicular is equivalent to 30 sine 20. So just a simple way to remember that the component of the vector which is written with an angle is always written with cosine, and the component of the vector which is written with, which is opposite to the angle, is always written with sine. So next to the angle cosine, opposite to the angle sine. So it is irrespective of how the vectors are drawn. Just remember, adjacent one is always with cosine and opposite one is sine. So example, if I draw a vector, I drew a vector and say this vector is 100 Newton. But this time this vector is making angle with perpendicular, vertical. So this angle is given. And here we have, say, 70. So if we resolve the vector into the component, so this vector will have two components. One of the component will be perpendicular, another one is like the vertical, and another one is horizontal. Now, what is this vector? In terms of vector, if I want to write, what is the magnitude of this component? Because this is a component written next to the angle, so it will always written with cosine. So this will be 100, the vector, cosine 70. And this is a vector which is written opposite to the angle, so that will be equals to 100 sine 70. So the vector sine 70 and the vector cosine 70. The important thing is, because the vector remain the same, but the component changes according to the given angle. So if the angle is written with the vertical, the one which is next to the angle, the vertical one, is the cosine, and the perpendicular, the horizontal one, is sine. But if I have the same vector and the angle with horizontal is given, so we have the vector, this is 100 newtons, and we have the component of the vector with an angle and opposite. So what will be this component? So this will be 100 sine or cosine. So because it is written with an angle, so it will be 100 cosine 30. And it is opposite, so this will be equals to 100 sine 30. So simple way, this is called resolution of the vector, or decomposing the vector into the rectangular component. Another example, if we have the angle of the vector, say this is a vector, and the angle is given, this angle is given 20, and we have a vector 50 newtons. So it will have the two components. What is this component? Sine or cosine? What will be this component? Yes. Sine or cosine? Because it is with an angle, so this will be cosine. So this will be equals to 50 cosine 20. And this one is opposite to the angle. Opposite to the angle, so this will be equals to 50 sine 20. Is it clear? Anyone having a doubt or a question till this point? Any question or doubt about how to resolve a vector? For example, if I have two vectors which are acting so this is an axis, and you have two vectors and their angles are given. So this is 70 degree with the from the vertical, and this one is example 60° with the vertical. And the vectors, the magnitude of these vectors are also given. This one is example 10 newtons, and this one is example 15 newtons. Okay. We want to find the resultant horizontal and the resultant vertical. So we want to find the resultant horizontal and the resultant vertical. First thing, when the vectors are given and they're making certain angle, the first thing you will do, you will resolve the vector into the components. So for 10 Newton, one of the component will be pointing in this way, and the other component will point in this manner. Okay. For the 15 Newton, one of the component will point in this way. Direction is also important because when you combine the horizontal and vertical components, you should get the vector as a resultant of the two, and this will be the direction. Now, what is the magnitude of this vector? What is the magnitude of this vector? What is the magnitude of this vector? So it will be 10 cosine 60. What is the magnitude of this vector? The magnitude of this vector, it will be 10 sine 60 degrees. Same way, what is the magnitude of this vector? This will be 15 cosine 70. And what about the magnitude of this vector? This will be 15 sine 70. Now, I want the resultant horizontal. So this 10 sine 60 and 15 sine 70 both are acting in the same, they are horizontal and both are acting in the same direction. So if I want to find the resultant, so that resultant will be equals to 10 sine 60 plus 15 sine 60, so 70. So 10 sine 60 plus 15 sine 70, I'll get the resultant horizontal. What about the resultant vertical? The 10 cosine 60 is acting upward and 15 cosine 70 is acting downward. So if I need the resultant according to their magnitude, like the one which is greater, 10 cosine 60 and 15 cosine 70, so what we will do, we'll subtract them. So it will be 10 cosine 60 minus 15 cosine 70. Or other way around, depending on which is having a greater magnitude. Why I'm subtracting here? Because these two vectors, the vertical vectors, are in opposite directions. If they're acting in the same direction, in that case, I will add them to find the resultant. Is it clear, this example? Anyone having a doubt or a question till this point? Any question or doubt? Okay. Blue line be verticals. The blue line is actually the horizontal here. It, you can draw blue as a vertical, then opposite one will be there. Because what we did, it's not about the color of the vector. The main idea is like how we resolve them. So I was having, like if I separately resolve them, say I was having a 10 Newton. I was having a 10 Newton and it was making angle 60 here. So because always a component which is with an angle, so that component is written with cosine. That's why this was 10 cosine 60. And there was a component opposite to the angle, like this component which is opposite to the angle. That's why it is 10 sine 60. So the important thing about the resolution of a vector depends on the angle. Another similar example, but what if I change the angles and I want to find the resultant of the two vectors? So we have the two vectors. So this is 30 newtons and this one is 20 newtons. For this one, angle is given 45 degrees, and for this one, angle is given 30 degrees or 40 degrees. Now, first thing, look, direction is also important, like how to draw the vertical and the horizontal here. So, for example, if I draw the vertical like this and horizontal like this, is the direction of horizontal vertical correct? No. Why it is not correct? Because when I draw the horizontal in this manner and I do the vertical in this manner, so the direction of the resultant is not matched with a given vector. Because according to this diagram which I drew, the resultant is from tail of the first to the head of the last. So the direction of a vector should be in this manner. But because the vector is pointing in opposite direction, that's why when I drew the this will be the vertical. So this will be the vertical and this one will be the horizontal. And when we write these component, because this is written next to the angle, what will this component? If it is written next to the angle, so this will be 20 cosine 40. And this is opposite to the angle, so that will be equals to 20 sine 40. And theta should be in degrees, not in radians when you're substituting the trigonometric ratios. Here it's 45. So when we do, like example, this will be the horizontal. This will be the horizontal and this will be the vertical. Is the direction of the vertical correct? Is the direction of the vertical correct? Yes or no? Direction of the vertical, is it right? So direction of the vertical, no, it's not correct. Why it is not correct? Because when the vectors are pointing, the second vector should start from the head of the first vector. So the second vector should start, this is the first vector, the second vector should start from head of the first. And the resultant is from tail of the first to the head of the last, that should be the resultant. That's why the direction was not correct. So here, this is written with an angle. So if it's written with an angle, what will the vector? So this will be 30 cosine 45. And this is opposite to the angle. That's equal to 30 sine 45. Okay. Now, if you want to find the resultant horizontal and the resultant verticals, yes, we can draw here. If I want to draw vertical, I can draw this vertical here as well. That does not make difference. Answer will remain same. So if we need the resultant horizontal, so this is pointing towards right and this is pointing towards left because they are pointing in opposite direction. So to work out the resultant horizontal, we subtract them. So it will be 30 cosine 45 minus 20 sine 40. That will be the resulting horizontal. How to work out the resultant vertical? So if I want to work out the resultant vertical, both are pointing in the same direction. So we will simply add them. So it will be 20 cosine 40 plus 30 sine 45. Is it clear, this one? Any question or doubt in this?
No, sir.
Okay. Now these horizontal and the vertical components, the value, because the vector is a constant here. So if I have any vector, example I call vector V, and it is making angle theta with the x-axis. So this vector V will have two components. One of the component is with an angle and the other component is opposite to the angle. So this will be equals to V cosine theta, and this is equals to V sine theta. What is the relation between the angle and the, because V is a constant, like it's a fixed vector. So mean these horizontal and vertical component will change if I change the angle. So if I change the angle, like example, I increase the angle. I kept the vector same, but I increases the angle. So this angle is theta 1. Or I kept the vector same, the magnitude, the length of a vector is same, but I increase the angle. So I reduce the angle. The second example. So this is V, an example, this is theta 2. So now what will happen if we do the components, the horizontal and the vertical component? So this will be the horizontal, and this will be the vertical. So this is representing the horizontal component, this one is a vertical. Same way, this one is representing the horizontal component, and this one is representing the vertical component. So what you will find, so this will be equals to V cosine theta 1, and this will be equals to V sine theta 1. This will be equals to V cosine theta 2, and this will be V sine theta 2. So when we increase the angle, when the angle is increased, what will happen to the sine? The value of the sine will increase and the value of the cosine will decrease. If we increase the angle, the sine theta will have a greater value and the cosine theta value will be smaller. If the angle with vertical is given, or the horizontal is given. And same way, if we reduce the angle, the value of the cosine theta will increase, the horizontal component will increase, and the vertical component will decrease. So whenever we change the angle, we also change the horizontal and the vertical component. If the it's for horizontal, angle with horizontal is given. If angle is vertical is given, opposite will happen. But if angle with horizontal is given, as we increase the angle, the sine theta will increase, cosine theta will decrease. As we decrease the angle, cosine theta will increase the value and the sine theta value will decrease. But the vector remain unchanged. Is it clear about the resolution of this vector and how the sine and the cosine theta value changes? Anyone having a doubt or a question till this point?
Mm.